Hello engineers, I'm here today to bring you a tutorial on how to use my automated rover script. It's designed to allow you to automate rovers so that they can handle transporting ore from mining locations, patrolling around your base, doing a coordinated assault against an enemy base, and as you can see, this one has been automated using my script. And I'm going to show you how to set up something like this today. I am going to show you how to set up a rover using this really basic rover. It just has some lights, a beacon, connector, a little bit of cargo, and some wheels, and a front and a rear camera, and a battery, of course. What we're going to do is we're going to set it up so that when it fills up, it will drive back to this base, connect to this connector, unload when it's finished unloading, and the battery is fully charged. It will then disconnect, back up, drive over to my mining base, dock with its connector, get filled by the mining base, and then when its battery is charged, it will come drive back to over here and reconnect and then start the process all over again. So to do that, I have found that using 5 timers and 4 event controllers to handle all of the logic of monitoring cargo, monitoring our battery, connecting our connector, turning on lights and all of that. And then it just needs a programmer block to handle all of the driving. So let's get started with our timers. And then our event controllers. And then lastly, our programmer block. I also like to use a helm to make setting up all of our timers and our paths simpler. So the first thing we're going to go to our programmer block, go to edit, browse scripts. Now you should already be subscribed to my rover navigation mod. So I'm going to hit refresh, make sure I have the latest version. You want the V2 version of my mod, click copy to editor. I've got a README that has all of the different commands and settings. So if you ever need to refer to anything, you can look back here. There's nothing that we can edit inside the code, so we can just hit OK. And now all of the settings that we can change are inside the program block's custom data. One thing before we set that up is I've grouped all of my lights together into lights group. I've grouped all of my wheels into a wheels group. So we'll go to the programmable blocks custom data, and we can see all of the settings for it. We also have an example of what a path would look like that you can use to refer to when adding waypoints or editing paths. So I guess I should explain what I mean by a path. The way the script works is that it will drive a rover along a set of waypoints. So if we look at this example, the first waypoint, waypoint 0, as a GPS point. So the rover will drive to this point. When it gets within waypoint range distance of that point, it considers it reached. Go on to the next waypoint. It will drive at whatever this max speed setting is, overridden on a per waypoint basis. So, for example, this first waypoint has its max speed overridden to be 20 meters per second instead of the 10 that was set up above. So then it will drive to this next waypoint, and then finally to this third waypoint, which has the max speed overridden, and the waypoint range. So this waypoint range is very small, which means that our rover might have a hard time reaching it. I generally suggest keeping this over 3 meters, but there's a few cases where having it really tight is useful. We can see also it has this .tb, which will trigger whatever timer block you have after it. So in this case, it would, when it reaches waypoint 2, it will trigger TB start timeout. And then we can see that it also has this reverse setting, which will have the rover drive backwards to this waypoint. So after it reaches waypoint 1, it will then drive in reverse to waypoint 2 at a speed of 2. There is another modifier, no collision, which will turn off collision detection when it's driving to a waypoint. This is useful for like when you're docking, so that it doesn't see the connector that it's trying to dock to and turn to avoid it. So that's how this script works. It just follows waypoints. The only exception is if you have combat, the combat maneuvers enabled, and you have a target designating turret that detects an enemy, it will instead do some combat maneuvers. So the tactic is the type of maneuver. So this one, the default is circle, which means it will circle the target halfway between max distance and minimum distance, and it will try to keep whatever side facing the target. You can look at the README for what other tactics are available. We have combat maneuvers disabled, and we're going to leave that because this is just a cargo rover. So that's what this waypoint range and max speed are going to be the default. If we don't set anything for a particular waypoint, it will use these. No brakes. Whenever the script completes an action, it by default will apply the brakes. If we set this to true, it won't do that. While we're setting up our paths, we want to set this to true because we'll be using the waypoint function to add waypoints to our path, and we don't want it to be applying the handbrake every time we add a waypoint. Tank steering uses tank style steering, so it reverses the wheels on one side to help the rover turn. It also uses any configured gyroscopes to help that turn. Boat mode will not use wheels and will use thrusters to move around. It's also useful for hovercrafts, and it will also use gyroscopes for turning. We have a standard rover, so we're not going to use that. Gyro stabilization will use the gyros to try and keep the rover upright. So like when it's making a sharp turn, it will use the gyroscopes to push against the centrifugal force to help keep the rover from flipping over. We don't have any gyroscopes, and we're not going to be doing any sharp maneuvers or moving very fast, so we don't need it. The controller name, the controller that the script will use as the position and orientation of the rover. We have a remote control at the front of this rover. It's named remote control, so we don't have to change anything here. But you can use a cockpit. I could use this helm, control seats. Anything that lets you control a vehicle can be used. The next thing is the propulsion group name. So this is a group containing all of the propulsion blocks that we want the script to use. It defaults to propulsion, but we have a group called wheels that contains all of our wheels. This can also include thrusters. If you were using them to assist your rover, or you were building a hovercraft or a boat, you can use those. Gyro group name, same idea as propulsion, except for any gyroscopes you want the rover to use. We don't have any gyroscopes, so it doesn't matter for us. Debug LCD. So while it's running, the script will log any warnings or errors that it encounters. So like if we didn't have a propulsion group, it would log an error telling us that we need to set that or make that group. And by default, it uses the programmable blocks large screen. I want to use this helm small screen. So there's a small screen up here. And I know that that screen is the first screen in the list of screens on the helm block. So Space Engineer starts counting from 0. And likewise, I want to use the helm's large screen, which is the second screen. And we can see that. Rename my helm to just helm. But we can see that the small screen is the first screen and the large screen is the second screen. So if we go back to our programmable block, we can see that I now have those named. For that collision detection, we'll use a camera, shoot out a fan of rays to detect objects. And so here we can set the camera that's facing forward and the camera that's facing rearward. By default, they are front camera and rear camera. I already have those named, so we don't have to edit those. But if you had a different name, you would put those here. The next couple settings, so these 3 are for the speed controller, and it's a PID controller that controls how quickly the rover accelerates, slows down. Generally, these are pretty good. If you're finding that your rover is really slow to accelerate, you can bump up the KP or the KI. Or if you're finding it's overshooting speed, you can bring those down or increase KD. But the settings that are here usually work fine. Next setting is safety margin. So when the rover is navigating around an obstacle, it tries to keep safety margin number of meters between it and that object. An important note, the script does not take into account subgrids when it's figuring out the size of the rover. Subgrids include wheels. So since my wheels stick out past my rover's edges, I need to increase this to include an extra space so that our wheels don't hit anything. 2.5 will put a whole large grid block worth between us and whatever the obstacle is, so that will easily account for the size of my wheels. And then I have collision avoidance turned on, so that's all we need to do in here. Now we just need to set up our timers and our event controllers so that we have all of our outside logic set up. So I'll start with our timers. So the first one is going to be our docking timer. And so it's just going to handle everything that we needed to do when we dock. So it's going to lock the connector, set the battery to recharge, turn off our lights, and turn off our beacon. And then we also want to run the stop command on our programmable block. That's going to tell the script to stop doing anything, cancel the current path. And we want to do that when we dock so that the wheels aren't flailing, wasting power. So that's our docking set up. Then we want to set up our undock timer. It's going to be basically the same thing, but in reverse. So we'll turn on our beacon, turn on our lights, set our battery to auto, and unlock our connector. We don't have to do anything with the programmable block because we'll do that in a different timer. So next, we'll set up our timers for starting the 2 legs of our journey. So this is going to be going to our mine site. So we'll start with going to pickup. So we're going to pick up ore. We're going to set up actions. We're going to undock. And then we're going to tell our programmable block to run a path and then the pickup path. So we're going to name our path that goes to the mine site pickup. And then our return to base timer will do the same thing. So it will trigger the undock and then run a path return to base. And our last timer is going to be called by our script when we're getting ready to dock to enable docking. This relies on turning on one of the event controllers. so we can't set that up until we get that event controller set up. So let's get that set up. Event controller, docking. It is going to be looking for when the connector is ready to connect. Set up our actions. We want to trigger our dock timer block, and then on the second page, we want to turn off our dock event controller. That way, when we disconnect, we don't immediately reconnect. Now we can go back and set up our enable docking timer, which will just turn that event controller back on. So now we have that. We'll set up our battery monitoring time event controller. So it will look at our stored power when it's 100%, because we want to know when our battery is fully charged. So we'll select our battery. And then for actions, what this event controller is doing is it's going to prevent us from leaving a base until our battery is fully charged. So to do that, we're going to turn off our action, because we're looking at when the battery is fully charged. When it's fully charged, we want to turn on the timer, and we want to turn it off when the battery is not fully charged. And we'll do that for both of our start timers. This way, we won't be able to start the sequence to return until our battery is fully charged. Now, that may make you think that, whatever's going to be triggering those timers isn't going to work because they're going to be off. But timers will still, when a timer block is off, you can still start the countdown. It just won't count down until it is turned back on. So in our event controllers, let's say when our cargo is empty, so after we've unloaded, so cargo is less than or equal to 0 on our 2 cargo containers, we want because we want when both of them are empty, we can start our timer, which will then wait until it's turned on by the battery monitoring event controller, and then it will start counting down to leave. And then our full event controller monitor when our 2 cargo containers are full. We'll do and again. And so when our cargo is full, we'll return to base. We'll start that timer. So now that's all of the logic that we need to fully automate our rover setup. We just need to make the actual paths that will be driven by our programmable block. Now we can see that those 2 screens on our helm haven't changed, even though we changed the configuration of the programmable block to say to use them. We need to tell the programmable block to reload its configuration. I am also going to add the handbrake on and off to my hotbar. And now if I press 2, we'll see that the 2 screens have updated on our helm. If we go and edit the text, we can read more easily what they say. So here we see that it couldn't find the programmable block with surface 0 or the cockpit. Those are the original 2 LCD screens that was configured with. Likewise, this propulsion group was what was originally configured with. We've already changed all these, and the reason why they still show up here is because the log doesn't clear itself after a change is made. That way you can always refer to it to see what error happened in the past. If you want to clear it, we can go to the programmable block, scroll down, and run the clear command, which will clear those 2 screens, as you can see behind my menu. And if we go back to the helm and edit the text, we can see our log just says log cleared. So now that we have those set up, we can start setting up our path. So I'm going to add another run command that's going to do a waypoint. The waypoint command adds a waypoint at the current position to a path. The second argument is the path name. So since we are already at our main base, we're going to be adding waypoints to the path driving to our pickup location. So now we're ready to start adding waypoints. I'm already lined up with my connector, so the first thing I want our rover to do is just kind of pull away from base. I'm going to add a waypoint here. You can see on the screens that it's printed out some information. So it's saying what path it's adding it to. In this case, because the path did not exist yet, it's created it, and then it's adding a waypoint, and then updating the path. And we can see on our log, there's also a log message telling us that we've done that. Now we're ready to just drive the path we want the rover to follow. And we'll add waypoints whenever we make a significant change in direction. So in this case, we can see that I'm passing the ramp to our base. So I'll add a waypoint here. And then I'll drive over to where that line connector GPS is. Wait for our other rover to drive by. So now once we get close to here, I'll add another waypoint. And then I will line up with this connector to set up our approach waypoints. I left our event controller on, which has docked our rover. And we can see that it's turned itself off, and one of our timers is counting down. So we know that all works. So now that we've disconnected, we'll just pull back, about 50 meters from the connector and add a waypoint. So these next 3 waypoints are going to be just for getting the rover well lined up with the connector. So I'm going to go roughly halfway, add another waypoint, and then since I already have a GPS waypoint, GPS point that's above the connector we want to connect to, I can just use that for my final waypoint. So to do that, I'll go into my GPS menu, click on the Mine Connector GPS waypoint, copy it to my clipboard, go back to my control panel and to my programmable block, go to the custom data, scroll down, we can see our path is here, and then I'll just add a new waypoint menu. So the number here is the waypoint index. It's just used to order the waypoints and to tell what waypoint these modifiers go with. So we just need a index that's higher than any that exists already. So I can do like 7 and then GPS because we're setting the coordinates, and then I just paste from my clipboard, and now I've added the final waypoint at this GPS location. Now you might be concerned because we can see that GPS point is quite a bit above the connector, but the script automatically projects all of these coordinates onto the plane of the rover. So the height above the rover or below does not matter as far as the script is concerned. That way, if you're like making a boat that's automated, if the water mod is making the sea level rise really high because the tide is in, it will still work fine. So now we've added that last GPS. Let's go back to our custom data. Now you also notice that these are not in order. The script doesn't care about the order, but it is much easier to think about if we do put them in order. Now, for that first waypoint, we were backing away from the base connector. So we'll want to add the reverse modifier to that waypoint that will tell the script to move backwards. Next, for this last GPS, if we were moving at 10 meters per second when we tried to connect, we'd likely damage our connector. So we want to set the max speed. So I'll just copy this one. And then because that last GPS point is right on top of the connector, we need to get as close as we can to it. So we want to set our waypoint range to be very close to it. Obviously, 0.2 would have us being inside that connector, but our docking event controller will have a dock, which will tell our programmable block to stop before we do that, which brings up we need to tell our script to enable our docking. And since it only triggers timers blocks when it reaches a GPS point, we'll do the GPS before. So waypoint 4 will activate our timer block or enable docking, and I want to make sure that I get that name right. So I'll just copy that and paste it into here. Now, the default speed we have set is 10 meters per second. Trying to jump all the way down to 2 is a pretty big jump in speed, so for 4, I will also lower the max speed somewhere in between, so like 5 meters per second. That way we'll slow down gradually as we come into dock. And with that, we should have this path all set up. So we'll hit OK, exit out. Now, since we've made changes to the settings, we need to tell the script to load those. So we can see that our config has loaded. Now we can drive back and run this path to check and make sure that we got everything right. But since our next path is driving back anyway, we can set up our return to base path while we're driving back. So I've just gone back into my G menu. I right-clicked on waypoint to change what the command it's running. I'll just change this to waypoint, and then I'll return to base path. It's called RTB. Confirm. So now when we add a waypoint, it will add it to the RTB path. So we're lined up with our connector. We want to back up a good distance before we add our first waypoint. And then just like before, we'll add our waypoints. Every time we make a big change in direction, so we'll drive past that, add a waypoint, drive over. We're close to our connector, so we'll add a waypoint. And now we'll get lined up with that connector really well. And go ahead and take your time getting lined up. It is worth it to take your time and do it right the first time. So again, we're going to back up 50 meters or so, add our first approach waypoint, then about halfway between, add our second approach waypoint, and then this time we'll just press up against that and add our third. And just like before, we want to make a few changes, so we'll go to our custom data, scroll down. We can see our pickup path is still there, just like we did it before, but now we have this RTB, and I'm just going to correct the order. Again, the script doesn't care, but it makes it much more readable for us. And just like before, that first waypoint, we're going to be back reversing away. And our second to last waypoint, we'll want to slow down and enable docking. And then for our last waypoint, we want to slow down even more and make our waypoint range really small. And this is one of the examples of why you would want that. Because this waypoint is set where this remote control is, we need to get very close to this position in order to be in range of our connector to connect. So that's why we set our waypoint range really small here. But with that, we have both our paths set up. And we have all of our logic set up. Because we did connect to our mine on accident, our rover's inventory is full. So if we just dock now, everything should be taken care of. So our cargo should be emptying out, or not. Is my base full? My base's cargo is full. Okay. I'm gonna go fix that real quick. Well, you can see that it worked.
Fuel critical.
So now we can see that on our status screen, we can see it's printing out the path, the waypoint name, the distance to that waypoint, our speed, whether we're going in reverse. Now we can see that it's toggling our handbrake on and off. That's because our speed is really small. And now we're seeing a problem. Now what's happening here is that the collision detection has detected our mining base, and it's trying to avoid it. So that's something that we want to disable. So we can just take this no collision and apply it to our last waypoint. And we'll probably want that for our other one. So now that we've done that, so the way I got it to stop running its command is I told it to reload the config. I'll do that again, so that picks up that no collision setting. And then I'm going to drive back to our original connector. And I will just manually tell the programmable block to run our path pickup. So we can see that it's driving to our mining base like we wanted. And now we can see that's on the mine connector waypoint, and we can see collision avoidance turned off. And we docked. And now we're filling up our cargo. Cargo is full. We can see our timer block counting down. Now, one thing you might notice is that our timers have not turned off, even though our battery is below full charge. The reason for that is that the battery hasn't reached full charge yet, so it's never triggered the battery event controller. I happen to know that this path unloading takes long enough that our battery charges a little bit each time, so it won't be a problem for this. But you can always just turn off these timers and then once the battery fully charges, the event controller will turn them back on. And so we've completed, we've docked, we should be unloading, but our base is still full. Alright, so now we can see that our timers turn off correctly when we leave, because the battery drops below 100%. And now we're driving back to the mine to get another load of ore. And so this rover has its connector on its front, so it's relatively straightforward for it to dock up. But this other rover has its connector on the back. And so if we watch it, we'll see that it has to turn around before it connects. So here it's driving forward. Now it's turning to back into that connector. And so you can turn any rover into an automated rover with just the addition of a couple of logic blocks and my automated rover script. And the same logic can work for gases, can be used to carry ammunition to far-flung defensive positions. With a little bit more logic, you can have it do multiple stops. So yeah, have fun, stay creative,